The Large Hadron Collider is going to be turned on. It is 17 miles in circumference. It is the largest machine of science ever built. You could put Manhattan inside. Ever since its launch on September 10th, 2008. The Large Hadron Collider has become a major milestone for the scientific community. 5, 4, 3, 2, 1. Stable scientists now have the means to test out particles and explore the subatomic world in a way that would bring life to famous theories like the Big Bang, the inside of the Big Bang. There should have been equal quantities of matter-antimatter, which annihilated, driving the Big Bang. So by rights, we shouldn't be here. The LHC potentials are almost limitless, but with all its potential, there are still some risks and possible disasters associated with this instrument, and many have been wary of what catastrophes it may cause to our world. CERN has discovered something new in this collider, something totally unexpected that has drawn the attention of several renowned physicists, including Michio Kaku. If I touch it, it would explode and destroy all of New York City, parts of Connecticut and New Jersey. This is one of the greatest mysteries in all of physics. What is this new thing birthed in the LHC? How does it help our understanding of the universe? And should we be concerned about our safety? Join us in this video as we explore Michio Kaku's announcement and weird things going on after they turned on the Large Hadron Collider, while instruments like James Webb allow scientists to peek into the far-reaching parts of the cosmos. Instruments like the LHC allow scientists to test out cosmological theories and explore the vast subatomic world of physics. This massive structure took 10 years to build and cost $5 billion. Is a massive project involving thousands of workers and a great deal of space. The Large Hadron Collider measures 27 kilometers in its circumference. It is located in Geneva, Switzerland, buried about 500 feet underground. It takes about 200 million watts of electricity to power this massive equipment. That's about the same amount of electricity it takes to power a small city. CERN spends about $23.5 million annually on electricity costs alone for the LHC. So as you know, the LHC is nothing but a particle accelerator with chambers for colliding particles. It supercharges protons and then smashes them together inside the chamber. It sounds like a simple process, but many technicalities are involved. In short, no other instrument on Earth can do what the LHC does at the same speed, accuracy, and volume. The vision of this project came after scientists discovered that the previous particle collider was inefficient for deep studies. The theory of particle physics was established as far back as the 1960s, but has not been experimented on. At the time, scientists realized that protons and neutrons contained 3 tiny point particles called quarks. Particles that are made up of quarks are collectively called hadrons at the time. There was no way for these quarks to be extensively studied. The only option then was the 3-kilometer-long Stanford Particle Accelerator. And so the idea of a larger multi-billion-dollar collider was born. Renowned physicist Michio Kaku once shared how he made a particle accelerator in his mom's garage, $10 billion building, the Large Hadron Collider, an atom smasher, outside Geneva, Switzerland. Now, when I was a kid, I had my first taste of atom smashing using 300 pounds of transformer steel and 22 miles of copper wire. The 2.3 million electron volts particle accelerator he made is nothing compared to the LHC, but it consumed about 6 cow of electricity and would still blow up everything in the house when he turned it on. The Large Hadron Collider is truly a wonder of science. This massive structure consists of around 10,000 magnets kept at a near absolute zero temperature of 1.9 Kelvin. This extremely low temperature aids the magnets to operate in a superconducting state. To maintain the near absolute zero temperature, scientists use a helium-based coolant, about 96 tons. All this sophistication aids the LHC to accelerate protons up to the speed of light and cause them to collide with the energy of up to 13 tera-electron volts. To put it in perspective, the collision force here is way more than what you'd experience if two supersonic jets collided head-on at top speed. In fact, Michio Kaku fondly calls the LHC the atom smasher. But you may wonder, what would scientists stand to benefit from colliding particles at such speed? Well, the main purpose of high-speed collisions is to break up these protons into even smaller subatomic particles. Scientists hope these collisions may bring about a groundbreaking discovery of some theorized or previously unknown subatomic particles. Simply put, scientists at CERN are trying to birth some extraordinary particles like quarks. You see, when the universe was still very young, about a few microscopic after the Big Bang, it didn't have matter protons or neutrons of any sort. Rather, the universe at this point contained something scientists call quark-gluon plasma. Simply put, this was a blend of subatomic particles 1,000 times hotter than the core of our sun. Scientists at CERN decided to recreate this substance, so they conducted a series of LHC experiments called Project Alice. The project basically involved colliding giant lead nuclei containing over 200 hadrons each. The experiments began officially on November 8, 2010, and 1 year later, in May 2011, the team in charge of this project announced that the quark-gluon plasma had been successfully synthesized. They repeated the experiments a couple more times, despite the possible risks involved, to say the least. This entire project was risky because the quark-gluon plasma originally should only exist in neutron star cores. Scientists even believe that the plasma in these stars could cause massive explosions if they ended up in our laboratories. And so you can literally say that as far as this project was concerned, CERN was playing with fire. Although there were no explosions, the team did admit that synthesizing this quark-gluon plasma inside the Large Hadron Collider caused huge energy bursts. Apparently the pressure and temperature and the pressure weren't high enough to make supernova explosions happen. The quark-gluon plasma created quickly expanded and cooled, transforming to hadron. And so while the experiments were successful, scientists didn't recreate the Big Bang phenomenon as they had hoped, since this substance was there. In the beginning, scientists had hoped it would somehow expand continuously, as it did in the beginning, creating matter. But it is suspected that this didn't happen due to the ABS of one very important particle. The God particle. Scientists believe that something happened just before the Big Bang. They call it inflation. According to conventional theory, the universe swelled to the size of a coin right before the Big Bang. This inflation helped the universe keep spreading and expanding, rather than condense under its own gravity, and return to become a single point. Scientists have no idea what caused this inflation. But one theory says it was caused by a special substance called inflation. In any case, LHC is the only equipment that can prove whether this inflation theory is true. One theory LHC has proven is that of the God particle, or the Higgs boson. You see, the high-energy collisions in the LHC are quite unpredictable. Records from CERN show that about 1 billion collisions happen every second. When this particle collider is turned on at that rate, it's difficult to tell what kind of particles would be formed. See, scientists do these experiments hoping to find extraordinary stuff, like inflat dark matter, or quarks. But while they didn't find any inflatons, CERN has surely found the God particle, proving its existence and the validity of the Big Bang theory. While inflaton caused the inflation, the God particle made the explosion and matter creation possible. Think of it this way. The universe was like an empty, useless crystal. But then it exploded, giving birth to everything in it, without the God particle. It wouldn't have exploded, as Michio Kaku rightly put it. The Higgs boson is the fuse that set off the Big Bang. Without the Higgs boson, the universe would have been a huge, useless gas of particles with no mass at all. One of the core aims of CERN is to recreate the God particle, or the Higgs boson just as it was in the beginning, since it is the very thing responsible for the creation of mass and matter after the Big Bang. The idea of the Higgs boson was first postulated by British physicist Peter Higgs in 1964. Back then, there was a major question with the Big Bang theory, the question of how particles attained mass. If the universe was formed out of nothing, how come about the mass we find in everything, both in the cosmos and here on our planet? It was a total mystery, until Peter Higgs came up with a Pla-Ibel theory. Peter Higgs assumed that these quarks experienced resistance from an unknown field that exists everywhere in the entire universe. This mysterious field was called the Higgs field, and the particle it contains was called the Higgs boson particle, or the God particle. From then it became a dream in the science community to recreate this God particle. Scientists discovered that the only way they could reproduce such a particle would be via high-energy collisions, since this is something only the LHC can do. The LHC became the first accelerator with the possibility of creating the Higgs field, setting off a spray of God particles in the process. This possibility became a reality on July 4, 2012, when two CERN research teams announced they had spotted the Higgs boson. It turned out to be much heavier than expected, about 130 times heavier than typical protons. This also hinted scientists that the Higgs field is an abnormally high-energy field, even in its steady state. The discovery of the Higgs boson was an instrumental landmark in scientific research, earning Peter Higgs the Nobel Prize in Physics. In 2013, the discovery attracted so many experts, including Kaku, who explained that this discovery could help us explain how things were before the Big Bang. We could get information about what or how life was before creation. This is because the Higgs field passes through everywhere and everything we know and see in our universe, including the empty spaces between galaxies. Without the Higgs boson, matter, as we know it, would not exist. However, the sad thing about the Higgs boson particle discovery is that it quickly breaks down into other particles as soon as it's created. This has left scientists in a dilemma, and they suspect that there must be a piece of the puzzle that we're still missing. In search of this missing piece, CERN scientists aren't relenting in their experiments with the Higgs boson. But given the high-energy nature of the Higgs boson, it makes the experiments in the LHC dangerous. What if CERN unintentionally releases a tremendous amount of energy that turns all planets and galaxies into subatomic particles and radiation? After all, Kaku did share during an interview that the goal here is to recreate a mini Big Bang, or a mini universe, that could be studied. So should we be worried, after the Big Bang, that are up to 10 times bigger than the Milky Way galaxy, that shouldn't happen? Although CERN has reassured the public of the safety of the LHC and its experiments, there's still a chance that the Higgs boson the organization is currently playing around with could set off a series of chain reactions. Such an event would cause a massive release of energy, which may not end well for the facility or the entire world. It could literally cause an inflation bomb, because in truth, the exact parameters of the Higgs field are not known. Scientists are simply treading in unknown, dangerous waters. If you do the math, CERN's Large Hadron Collider typically results in over 86 trillion collisions every day. It's powered on, meaning there are a trillion chances for something to go wrong. This is why the LHC has always been controversial, not just to the science community, but also the world scene. Many people, Scientists and non-scientists alike consider the Large Hadron Collider a ticking time bomb, while the entire structure of the LHC may be safe and predictable. The same cannot be said about the particles colliding inside its chambers. The fact that the Large Hadron Collider is located in a region with about 600,000 people makes it even more disturbing. If something were to go wrong with the LHC, there would be thousands of casualties. It's important to point out here again that these scientists are trying to recreate some of the particles responsible for the Big Bang. And so what if they end up creating some Big Bang all over again? This has been a major cause of concern for many. But there's even more. The renowned British astrophysicist Martin Rees disclosed that the Large Hadron Collider could cause quantum black holes to form right there in the collision chamber due to the high concentration of energy in that space. However, the CERN scientists disproved this, hinting that the energy with which protons collide in the LHC is lower than what it would take to form such quantum black holes. But this hasn't been substantially proven, and some experts still believe that the LHC could create a quantum black hole. Quantum black holes are mini black holes. These black holes may not be able to suck in matter like their space counterparts, but according to Stephen Hawking, they can release a powerful wave of radiation. Some experts suspect this violent radiation surge must have been responsible for the LHC's collapse during its first launch in 2008. During that incident, it was reported that about 100 magnets in the Large Hadron Collider had suddenly overheated and caused several tons of helium coolant to leak out. Thankfully, no one was hurt, but it raised questions about how unpredictable and dangerous the LHC could be. This incident also alerted CERN on the need for periodic maintenance of this massive scientific research instrument, and so the LHC is usually turned on for about 2 to 3 years, and then shut down for a similar duration to undergo maintenance. So far, no incident like the one of 2008 has occurred again. But the long maintenance time still leaves people wondering if there are some things these scientists are covering up to avoid public disapproval of this equipment. Perhaps they've spotted quantum black holes Stephen Hawking's predicted, or something even worse. But what could be worse than a black hole? There are a couple of things, actually. Physicist Michio Kaku has predicted that the LHC could help us create dark matter, the invisible strange particle responsible for the expansion of our cosmos. But then again, other experts believe it could create certain strange, unseen effects in our world. One such disturbing possible effect of the Large Hadron Collider that is believed to have happened already is the Mandela effect. The Mandela effect is a strange phenomenon when people misremember events, historical facts, and other notable moments that are supposed to be common knowledge. Just so, this isn't just a movie thing or fiction. It is something that has been observed in thousands of people all over the globe. What's odd about this phenomenon is that it was first noticed in 2009, not long after the launch of the LHC. The popular story surrounding this phenomenon is the well-known story of Nelson Mandela while fighting for his country's freedom. Mandela was sentenced to prison, but his people gained independence and he was released and made the first president of South Africa in 1994. However, it turns out that many people have another version of this story, hence the name Mandela effect. This controversial version was first shared in 2009 by a lady who goes by the name Fiona Broom. She had a memory of Nelson Mandela dying in prison, and several other people she asked confirmed the same thing. Some even claimed they remember seeing news coverage of his death and a speech by his widowed wife. How could so many people have the same memory when it never happened? The similarity in the memories and the accuracy of details sure implies that something very mysterious is at play. Several other scenarios and events apart from the Mandela story from all over the world seem to validate this phenomenon when considered closely. The Mandela effect can be very disturbing because it seems that some folks were reading entirely different news or were exposed to an event entirely different from our reality. M. Ding asked, "What is your name?" I told him, "My African name says no. I don't want that one." It makes you wonder if the theories of parallel universes are true. Several physicists have come out to blame the Large Hadron Collider for this global catastrophe. Among them is Mark Laughlin, the once popular internet child genius. Many people compare to Nikola Tesla. According to the young man, CERN is to blame for the Mandela effect, as they sent humanity to a parallel universe with the LHC experiments, although there isn't any proof to his claims. The coincidence of it all just makes it too hard to dismiss. What if this young Einstein is actually right? Did the Large Hadron Collider do something to mess with our minds, or transport us to parallel universes? So many theorists and conspiracy theorists still believe that CERN is creating unseen portals to other dimensions with the Large Hadron Collider, which is causing strange effects, like delusions, reality shifts, and rips in the space-time continuum. While we're not sure of these, one thing we're sure of is that several unbelievable and uncommon discoveries are going to birth out of this scientific instrument, some of which will be hard to explain, and we're already in that reality, as CERN has just announced that something weird was discovered in the LHC. It is something that got the whole science community buzzing with excitement. The Large Hadron Collider just revealed a new type of subatomic particle never seen before. Scientists are calling it a pentaquark. This particle was so named because it contains 5 quarks, 4 quarks, and 1 antiquark bound together. It is the first of its kind, as it had never been seen. Elsewhere, scientists have also confirmed that this type of particle doesn't occur naturally and cannot be recreated outside the conditions found in the LHC. In case you're still wondering, what makes this special? Remember, we talked about quarks and how they are the fundamental constituents of matter from the lens of particle physics. Well, usually most particles, also called barons, only contain 3 quarks. A 5-quark particle was only thought to be a myth, at least until this recent discovery, but it doesn't end there. CERN has also shared the discovery of another particle, the first ever pair of tetraquarks. These are 2 of the most recent discoveries from CERN before the LHC was shut down for maintenance in July 2022. Tetraquarks are subatomic particles with 4 quarks. They've been confirmed to exist before, but never in pairs. These 2 discoveries are ample proof that the Large Hadron Collider helps CERN scientists to dig into far deeper reaches of the subatomic world than we thought possible. They also proved that several other particles exist out there that we know nothing about. It just makes you wonder what unexpected discoveries will spring up in the coming years. Now scientists at CERN are planning to build another Hadron Collider bigger and better than the current one in Geneva, Switzerland. The project has been named the Future Circular Collider. Kaku has shared that different nations are already competing to host this machine, so it won't be in Switzerland this time around. This proposed collider will measure about 100 kilometers in circumference, and it will be able to collide particles at an energy of up to 100 tera-electron volts. Maybe we'll finally be able to create and keep these elusive particles stable. The project's estimated cost is $22 billion, and it's expected to be completed by 2050. Scientists believe a bigger Hadron Collider will allow them to push the boundaries of science and better test the many unverified theories in science, but some believe we're just pushing our luck too far. Thanks for watching another episode of Voyager while you are still here. Click on the video on your screen for more quality content.